What if a storm in space could knock out your phone, disrupt airplanes, or even shut down an entire city's power grid? It might sound like science fiction, but these storms, driven by the sun's energy, are very real. To uncover how this happens, NASA has launched the TRACERS mission on July 23, 2025. Using 2 satellites flying in formation, TRACERS will study a powerful space process called magnetic reconnection, unlocking secrets about space weather and how it affects life on Earth. Let's get started. Why TRACERS matters. Space might feel distant, but its effects reach us every single day. The sun constantly sends out streams of charged particles known as the solar wind. Most of the time, Earth's magnetic field protects us. But sometimes, energy from the sun slips through cracks in this shield, causing geomagnetic storms. These storms can interfere with satellites, navigation systems, internet cables, and even electricity grids. That's where TRACERS comes in. NASA designed this mission to look closely at the exact moment when solar energy breaks in. By understanding this process, scientists hope to predict space weather better and reduce the risks it poses to modern technology. It's not just a science project, it's a shield for our future. The mystery of magnetic reconnection. At the heart of TRACERS lies one scientific puzzle: magnetic reconnection. This happens when magnetic field lines from the sun and Earth meet, snap, and rejoin in a new shape. Imagine twisting 2 rubber bands together until they suddenly snap and release energy. That's similar to what happens in space, except with huge amounts of energy that can heat plasma and accelerate particles to incredible speeds. Magnetic reconnection is one of the most powerful processes in the universe, influencing everything from auroras in the sky to dangerous radiation storms. Yet, despite its importance, scientists still don't fully understand how it works. TRACERS will finally provide the detailed measurements needed to solve this cosmic mystery. Twin spacecraft, one mission. What makes TRACERS unique is its design. Instead of one spacecraft, NASA is sending 2. These satellites will fly in close formation, almost like dance partners moving together through space. By keeping them side by side, scientists can capture magnetic reconnection events from multiple angles. This is crucial because reconnection changes very quickly. It can happen in just fractions of a second. With 2 spacecraft recording the same event at once, researchers can compare data in real time. This gives them a clearer picture of how magnetic fields shift and how particles move during reconnection. In short, the twin design makes TRACERS more than twice as powerful, turning it into one of the most precise space missions ever attempted. The polar cusps, Earth's weak spots. TRACERS won't be studying just any part of space. Its focus is on the polar cusps, unique regions above Earth's north and south poles. In these areas, the planet's magnetic shield dips down, leaving openings where solar wind can stream directly into the upper atmosphere. Scientists call them windows into space. While beautiful auroras are often the visible result, cusps are also where space weather poses the greatest risks. By studying reconnection in these vulnerable zones, TRACERS can track exactly how energy sneaks past Earth's defenses. This is the first time such detailed measurements will be taken in these regions. For researchers, it's like setting up cameras at the weakest points of a castle wall to see exactly how enemies get inside. The instruments on board. Each TRACERS satellite is packed with instruments designed to read the invisible language of space. These tools can measure electric and magnetic fields, as well as detect ions and electrons zipping through plasma. Think of them as high-tech space weather sensors. Together, they'll provide a 3D view of what's happening during magnetic reconnection events. For example, one instrument measures the direction of magnetic fields, while another counts fast-moving particles. When the data is combined, it builds a full picture of the plasma environment. This technology is so sensitive that TRACERS will be able to capture over 3,000 reconnection events during its mission. That's more than any other spacecraft in history, making it a true record breaker in space science. A record-breaking mission. NASA designed tracers for a 1-year primary mission, but in that short time, it will achieve something extraordinary. Most spacecraft observe a few magnetic reconnection events in their lifetimes. Tracers is expected to record thousands. This massive data set will allow scientists to study reconnection not as a rare event, but as a constantly changing process. By seeing how reconnection evolves from one moment to the next, researchers can uncover patterns that were invisible before. Every measurement adds another piece to the puzzle, creating the most detailed timeline of reconnection ever made. Even if the mission lasts only its planned duration, tracers will leave behind a treasure trove of scientific data for decades of research. Protecting our technology on Earth. Why does studying space matter for people living on the ground? The answer is space weather. When solar energy slips through Earth's magnetic shield, it can cause geomagnetic storms. These storms interfere with GPS signals, disrupt communication satellites, and even overload power grids. In fact, a massive storm in 1989 knocked out electricity across Quebec, Canada, leaving millions without power. As our world becomes more connected through technology, the risks grow greater. Tracers aims to help by providing the knowledge needed to forecast these storms more accurately. If scientists can predict them in advance, power companies, airlines, and internet providers can take precautions. In this way, Tracers is not just protecting science, it's protecting daily life on Earth. Tracers and the science of auroras. One of the most beautiful side effects of magnetic reconnection is the aurora, the colorful lights that dance across the polar skies. Tracers will help explain how these lights form by studying the chain of events from solar wind to atmosphere. When particles from the sun enter through the cusps, they collide with gases in Earth's upper atmosphere, releasing bursts of light. While the aurora looks like art, it's actually science in motion. By connecting the dots between reconnection events and auroras, tracers will reveal why some storms produce spectacular light shows while others remain invisible. This deeper understanding could even allow scientists to forecast auroras with greater accuracy, making the sky itself part of space weather prediction. Collaboration and teamwork. Behind Tracers is a global team of experts working together to make the mission possible. Managed by the University of Iowa with support from NASA, the project brings together researchers, engineers, and students from many institutions. Each group contributes unique skills from designing instruments to analyzing complex data. This collaboration also gives young scientists valuable experience, working with real space missions, training the next generation of explorers. International cooperation strengthens the mission even further, showing that space science is most powerful when knowledge is shared. Tracers proves that progress in understanding our universe depends not only on advanced technology, but also on teamwork. What Tracers means for the future. The Tracers mission is a milestone for both science and technology. Its discoveries about magnetic reconnection will not only improve our ability to predict space weather on Earth, but also help us understand similar processes across the solar system. Planets like Mars and Jupiter also experience interactions with solar wind, and Tracers data could guide future missions studying their space environments. The mission also shows how smaller, cost-effective satellites can achieve groundbreaking results, inspiring the design of future space projects. By building this foundation of knowledge, Tracers paves the way for safer technology, deeper exploration, and a clearer picture of our universe's hidden forces. NASA's Tracers mission isn't just about exploring space, it's about protecting life on Earth. By studying magnetic reconnection in the polar cusps, scientists will finally understand how the sun's energy slips through Earth's shield and disrupts our world. These insights could safeguard technology, improve forecasts, and deepen our knowledge of the universe. If you enjoyed this journey, remember to like, share, and subscribe for more space stories. Thanks for watching. Until next time, keep looking up.